Welcome to this explainer. Today, we're diving straight into a totally fascinating mathematical framework developed by David C. Krakauer. We're going to take a really close look at the profound and honestly kind of complicated relationship between us humans and the technology we rely on every single day. We're tackling a fundamental debate here. Are our tools actually making us smarter, or are they just making us completely dependent on them?
It's a question that feels incredibly urgent right now, doesn't it? As we're all staring at our screens all day, we really have to ask ourselves, does technology strengthen or weaken human intelligence? There is just this broad cultural anxiety right now around AI, the decay of our own natural skills and the ultimate limits of human capability. Basically, we're wondering, are we outsourcing our minds?
To ground this abstract theory, let's think about a super familiar, everyday experience, navigating a new city. Now, if you use a physical paper map, you are actively building a spatial representation inside your brain. It's like a mental muscle. When you take the map away, your navigational memory persists. You know where you are. But if you just blindly follow the turn-by-turn directions of a GPS on your phone, your spatial memory and route-finding skills actually degrade. The GPS is doing all the heavy lifting, so your internal capability just completely atrophies.
Okay, let's quickly look at our cognitive roadmap for the explainer today. We'll start with the technology paradox, move to competence versus reliance, and then the power of prior learning. After that, we'll hit transparency and the scale gate, look at what happens when tools become agents, and finally, education in the AI age.
Section 1. The technology paradox.
So humans have literally always externalized our thoughts onto cognitive artifacts, right? From ancient clay counting tokens way back when to the modern abacus and now obviously large language models. But here's the thing, not all tools interact with our brains in the exact same way. A complementary tool is one where the competence actually transfers to you, the user. The skill sticks around even after the tool is taken away. It scaffolds a really efficient internal representation in your mind. A competitive tool, on the other hand, that makes you dependent. The more you use it, the more your tool-free competence is compromised. And the wild part about all this is that two different tools can serve the exact same task, but leave their users in entirely opposite states of intelligence.
Moving on to Section 2. Competence versus reliance.
Krakauer's framework brilliantly models the user, the tool, and the task as a single dynamic system, where your internal competence and your reliance on the tool are constantly co-evolving. Notice this curve here? It's what we call bistable. The top solid line, that represents you being in a highly competent state. The bottom solid line is a dependent state, and they're separated by that dashed, unstable threshold in the middle. Now, as you increase tool availability along the bottom axis, everything seems totally fine until you hit a critical tipping point. See that upper fold on the right? Hit that, and human competence literally falls off a cliff. You drop straight down into total dependence.
And here is the absolute kicker. You can't just turn the tool off to recover. Notice how the arrows on that last chart didn't just retrace their steps? This collapse is what's called hysteretic. Once you fall into that dependent state, simply lowering the availability of the tool a tiny bit doesn't magically bring your skills back. Actually, scratch that, it doesn't bring them back at all. You have to endure a massive, sweeping reduction in tool access to rebuild those internal skills from scratch. It's a tough climb back up.
All right, Section 3. The power of prior learning. So why is it that two people, given the exact same tool and the exact same amount of access to it, can occupy completely opposite permanent states of competence? Well, the answer lies in prior learning. That's what sets the threshold for what you can actually tolerate. Look at the blue dots here. An untrained agent, meaning someone who never truly learned the skill beforehand, collapses into dependence when the tool is available just 38% of the time. Just 38%. But look up at the top right. An agent with high prior learning, say an expert mental abacus user, they can withstand up to 87% tool availability before they lose their internal skills.
This perfectly illustrates the concept of an analog education. Your history of practice is what fixes your state, not the tool that's currently in your hand. Think about it. If you thoroughly mastered arithmetic before you were ever handed a calculator, your brain holds on to its unaided skill. But if you learn math with a calculator from day one, you never built that internal competence in the first place, and you are trapped in that dependent state right from the jump.
Section 4. Transparency and the scale gate.
Okay, so far we've talked mainly about the user. But what dictates whether a specific tool augments our minds or completely overflows them? It all comes down to a concept called transparency. Transparency is essentially the ceiling of your competence. It's the fraction of a tool's inner workings that you can actually reverse engineer in your own head just by looking at it.
A transparent tool, like an abacus or a physical map, exposes its mechanism. You can rebuild it in your mind. An opaque tool, like a GPS, it completely conceals its computation. It's a black box. There's literally nothing there for your brain to internalize.
Now, what's really interesting about this slide is how we can use this math to actually map out different tools. On this phase plane, the x-axis represents that effective ceiling we just talked about, basically transparency, and the y-axis is the task load. Over on the right side, you see the compass, the map, and the small abacus sitting safe and sound in the augmenting region. But check out the GPS on the left. It's trapped in the diminishing region because it sits way below that vertical dashed line, the opacity threshold. It's just too hidden to teach you anything.
And listen, we know this isn't just a bunch of theoretical math. Independent datasets across all sorts of disciplines prove this is a very measurable cognitive reality. For example, meta-analyses show that unused cognitive skills decay twice as fast as physical skills. We're talking a 48-day half-life for cognitive skills compared to 106 days for physical ones. We see airline pilots who overly rely on flight deck automation actively losing their manual flying skills. We see habitual GPS users showing severe spatial memory decline over a period of just 3 years. Yet mental abacus experts successfully retain their skills, all because their tool is transparent.
Section 5. When tools become agents.
So, what happens when we scale this whole thing up to large language models? Are we looking at the displacement of human agency itself? Well, an LLM can actually be either competitive or complementary, and it depends entirely on how you use it. If you engage in verified use, meaning you reconstruct the AI's method and actually verify its output, the LLM acts as a complementary coach. It augments your intelligence. But if you fall into accepted use, where you just uncritically accept the AI's answers as gospel, it becomes a competitive diminisher. It actively erodes your internal capability.
And here is the real danger zone. The scale gate. When an AI's model, its underlying policy for solving problems, is vastly larger than the human brain's acquisition budget, it becomes literally impossible to internalize. The transparency drops straight to zero. When that happens, we experience what's called agentic reversal. The human can no longer set the goals or even understand the methods. The agency itself transfers over to the tool, and the human irreversibly becomes just an instrument of a computational agent.
Finally, Section 6, Education in the AI Age. So how do we actually protect ourselves here? Well, Krakauer's mathematical model prescribes a very robust educational sequence to protect our cognitive capabilities. Step 1, build competence first. You absolutely have to establish that internal learning to push the student above that collapse threshold we talked about earlier. Step 2, introduce tools second, and strictly as a complement. Step 3, use transparent tools early in education and absolutely unequivocally delay opaque tools like AI generators or even calculators until that core competence is fully secure. The order in which we learn is quite literally what dictates whether an entire generation falls into a collapsed state or a highly competent state.
I want to conclude with this incredibly provocative thought straight from Krakauer's research. Do we want humanity to preserve agency or to become the embodied tools of an agentic tool? Wow. As we surround ourselves with increasingly frictionless technology every single day, we really have to evaluate our own reliance on it. Are the tools you use scaffolding your mind, or are they slowly replacing it? I want you to really think about that the next time you open a map app or ask an AI to write an email for you. Thank you so much for joining me for this explainer.